My name is Tim Jackman. I am a PhD student at Boston University in the Orthopaedic and Developmental Biomechanics lab. Our project seeks to understand how spine fractures develop. The very common fracture that's seen clinically is somebody bending over to pick up something heavy and they overload, say, the front of their spine, and they would create what's called a wedge fracture. These wedge fractures are fairly difficult to replicate in an experimental protocol like this. To do that, we use tissue from human spines. We remove 3 vertebrae and we'll apply a small amount of compression and then scan it and repeat the compression. Do this over and over and over until we see from the data that the bone has failed. The most challenging part is getting a device and an experimental method to work the way you think it should work. So to apply a consistent load, we need these cups that we've custom built for our micro CT scanner. As far as the design process, most of the technical design challenges have been overcome by the people at Epic.
We started out with Tim with just 2D drawings on paper. The idea was, how much strength is this going to have? Can we get away with what we want to do, which is essentially taking a couple of vertebrae and crushing them.
We need a cup that will just be big enough for our spine to fit in, and then we have a screw cap on the top that we need to be able to turn the screw to apply the force.
In a biomedical experiment, they haven't done the engineering to calculate what the stresses are. So we, as the engineering staff, started to say, well, you're going to scan through this material. What kind of wall thicknesses do you have to have? So we worked from there.
Things don't always go to plan, that's research, and the Epic staff are the ones that have come up with a lot of the clever inventions that we can do to actually make this work. It's been really fascinating to get data from actual human tissue that we've loaded and broken, and to see what happens every time we do. After we have that data, we will use it to create computer models so a patient could go into the hospital and we could run these models and identify people who would be at immediate risk for fractures, so we can do some intervention rather than fracture treatment later on after they've already fractured their spine.